Today we're going to talk about humidity control. Right now we have an air loop HVAC system. It's got chilled water coils, heating water coils, fan, and it's serving a bakery. And bakeries often have high humidity levels. So what we're going to do is implement humidity control on this system. Now, there's three different ways we're going to do humidity control. First way we'll talk about is ideal air loads, which has its limitations. And then we're going to go ahead and implement humidity control with a unitary air loop HVAC system. And then finally, we'll implement humidity control on this, this 4-pipe fan coil system. So first of all, let's save this as our ideal air loads. And let's see, we're going to, we'll just remove these and then we'll remove the air loop. We don't need the chilled water loop, condenser loop, or the hot water loop anymore because we're doing ideal air loads. And then we just turn on ideal air loads. So that's ideal air loads, and that's just sensible heating and cooling. If we want to implement humidifying and dehumidifying set points, we have to come up with a schedule, or we have to set that in the zone sizing information. So let's go to the zone sizing information. It's kind of counterintuitive with OpenStudio. You have to go to the Spaces tab and then select the thermal zone from there. And that will bring up this menu on the right, and we can scroll down and set. So right now it's only set to calculate sizing based on sensible load. First of all, we need to change this to sensible and latent load. The latent load is going to be the humidity that we're controlling. The next step is to set the zone dehumidification and humidification set point schedules. Now, for a bakery, we're probably not going to have humidification, but if it's going to be in a place like a hospital or other more sensitive areas that require humidity control during the wintertime to maintain humidity levels higher than what they would be, that's what you would use here. But we're going to do both. But in order to do that, we have to create a schedule, a humidifying and dehumidifying schedule. So let's go ahead and go to our schedules. And it's going to be a fractional schedule. It's going to be a relative humidity percent schedule. So we'll create add new object, and it's going to be percent. Click apply. So, and this is going to be our schedule dehumidifying. And we will just keep that at 50%. Likewise, well, let's see. Likewise, we need to create a humidifying schedule. So let's just copy this one, and we'll just rename it humidifying. And say we want to keep the humidity levels above 30%. So we'll just type in 30, hit enter, and that sets it to 30%. We're going to be running this simulation with just the design days. We don't want to run a full simulation just for testing purposes. So we want to set the design day parameters as well. So let's go to design day, and we'll just copy the default day schedule. And same with winter, copy the default day. That way they're all the same. And then we need to do the same thing for dehumidifying. So all right, so we have our schedules set up. Let's go back to the thermal zone and edit it. And we need to scroll back down to the humidistat dehumidification setpoint schedule name. So that's going to be dehumidifying that we just created, and the humidification will be humidifying. All right. Let me think here. So let's go back to the schedules, and let's take a look at the dehumidifying schedule. Say we want to control the schedule a little bit more controlled in the daytime, and we can set it back at night. So say like early morning, it will start the dehumidification control, and then mid-afternoon it will stop controlling it. So at nighttime we'll set it back to maybe 60, right? So during the day it's dehumidifying. At nighttime it's getting set back, so it's not doing so much dehumidifying. So and since we just did that, we need to update our design days, and let's just add that in here. All right. So now we have our schedules set. So the next thing we need to do is go to the Thermal Zones tab and assign those humidity control schedules to our thermal zone. So let's go to My Model and drag in those schedules. So we have a humidifying schedule here and a dehumidifying schedule here. So those are the schedules that are going to control our humidity for that thermal zone. And then the last thing that we need to do is pull in a custom measure. And the reason is because, well, let's go back to thermal zones. The reason is because in OpenStudio, the only way to actuate ideal air loads is just with this one checkbox. When in reality, the ideal air loads actually have quite a few inputs involved for controlling those. And all of these inputs are controlled at the Energy Plus level. So basically after OpenStudio passes the input file over to Energy Plus. So in order to do that, we've got a custom measure that will write those Energy Plus fields. And I'm going to put this onto the building component library. But here it is. It's this measure right here. And this will allow you to set the various control types for humidification and dehumidification for the ideal air loads. And you can read about these control types here and what they're used for, but really what we're doing is we're doing the control type humidistat. And the humidistat will look at those schedules that we assigned to the zone, and it will control to that to the humidity in the zone. Some of these other options, for example, the default option, the constant sensible heat ratio option, it also looks at it actually calculates a theoretical latent cooling rate. So it's not actually running the simulation. It's just calculating a theoretical cooling rate and developing a load from that. So that may not be reflective of the actual energy calculation, whereas the humidistat pathway actually looks at the schedules that we have put in. Now, the problem at the moment is that Energy Plus does not pass those schedules that we just created over to, Energy Plus doesn't keep those schedules. It actually overwrites them, and that's just a bug in the program. But for now, what I have done with this measure is written it so that it takes an average of our humidity schedule and applies that, and that's just a temporary fix. So what we'll do is we'll fill this in. I've already filled it in with the thermal zone name. We'll select the control type as humidistat for both of those. And that's all we need to do. And then we will run the measure. Run the simulation. Let's see. We want to make sure that, so we want to turn this off. We're just going to run the simulation for the sizing periods. We don't need to run a full simulation, so that will greatly accelerate our calculation. And we'll just take a look at the sizing period for that. And then we can take a look at what output variables we have. I think I've already have those enabled. Yeah, so we're looking at relative humidity here, and zone air temperature is a good one to have. So make sure you have those checked so we can take a look at the results. So let's go ahead and click run. The run completed successfully, and let's go ahead and take a look at the simulation results. And we are going to be looking at, let's go back and take a look at what our humidity run period is. So this one here will have the first two are humidity run periods. So this is going to be the most humid one. So we'll take a look at the second run period. That's going to be this one here. And then same with humidity, relative humidity, we'll take a look at that there. All right. So this is with humidity control, and you can see it's actually controlling pretty good. Humidity is in orange, and it's pretty flat across here. These dips are when the system starts introducing more outside air, or when the building becomes occupied or unoccupied throughout the day. And it looks like it is controlling zone temperature throughout the day. So it's set back to 80 at night, and then it becomes occupied, and it controls to 75 dry bulb during the day. So 75 dry bulb during the day, and it's controlling to 55 relative humidity. We can take a look at, let's see, the previous simulation, and it's going to be the SQL file without humidity control, and take a look at see what that looks like. And it's going to be this one here and this second one here. Right. So this is without humidity control. You can see it's controlling the zone temperature pretty well, the blue one. But the humidity is actually quite high. Starts out around 90. And as it cools down during the day, and it's cooling the space, it's also removing some of the humidity from the space. So it's slowly getting lower, but by the time it goes to setback, it's only at about it's just about met the set point by the time it gets to the the humidity set point by the time it gets to the setback, and then it jumps right back up. So this is the example of a system without humidity control, and then this would be an example of the system with humidity control. Another thing that I should note with ideal air loads humidity control is that it doesn't track reheat. So yeah, let me open up the air loop without humidity control. This is our original air loop. And this one doesn't have humidity control, but if it does, a real system, if it does have humidity control, it's going to have a reheat coil after the cooling coil, and that reheat coil uses energy. Unfortunately, ideal air loads doesn't actually track that heat use. So it's not a good use of ideal air loads is not a good use for actually doing energy simulation. It's only good for doing basically calculating loads. All right, so let's go back to our second case. Let's see, we can probably close this one and save this as unitary. I'm going to show you how to do humidity control using a unitary HVAC system. So we already have everything set up with the ideal air loads. This time I'm going to use a unitary system, and we'll go to the HVAC tab, and then we're going to add an air loop. Doesn't matter which one, because what we're going to do is we're going to delete all of these things. Let's see, I think we'll probably keep this one though. We'll add our zone to the air loop, and then we need to look for unitary systems. I don't actually have it on here, and it doesn't come standard with the OpenStudio HVAC library. So, but you can download that off of my YouTube Google Drive folder, and I'll provide the link in the description. And so we'll add that to our default libraries. Go to downloads and select this, and click OK. Right, so it should be in the library now. Unitary system dehumidify right here. So we'll drag this into our air loop and select it. And there are a couple of parameters that we need to set. So for dehumidification control type, it needs to be set to cool with reheat. You wouldn't want to use multi-mode on this because it doesn't have the right cooling coil. I believe it's cooling coils. It's yeah, multi-mode. Cooling, heat exchanger assisted. So if you select multi-mode, that's for an air loop unitary system that has a heat recovery coil, DX coil on it. But this one does not. It has just a simple DX coil with an electric reheat coil. So we want to keep this set to that the way it is. And then the other parameter that we want to control is this one, latent load control. So it's already set to latent or sensible load control. So that's the one we want to select. It has a few other modes. Sensible only is the standard mode. Latent only if this equipment is solely dedicated to dehumidification. And then latent with sensible load control is so the predominant control is sensible load control, and if it is trying to satisfy a sensible load, it will also dehumidify. However, if there is no sensible load, it will not dehumidify. So the one we really want is both sensible or latent. So we'll leave that the way it is. And that's pretty much it, how you set up a unitary system. Right, and so this is, yeah. So the coil that it has is a 2-stage with humidity control. So it doesn't have heat recovery on it. So that's it. So let's go ahead and run the simulation and see how this does for humidity control. So it failed. Let's take a look at the error output file and .err file. It's going to be these two here. Oh, okay. So this unitary equipment needs to have a thermostat assigned. Let's go back to the air loop and assign the thermostat. We only have one zone, on here. It could be that we have multiple zones set on our zone list, but we only have one thermal zone that this is controlling to. So it's not a problem for our purposes, but evidently this one has to have a master zone that it is trying to control the humidity in. So yeah, I'm not sure if you can do a polling set point, but at any rate, that's where we'll set the thermostat location. So let's go ahead and rerun the simulation. Failed again. Let's go look at the error output file here. Yes. And zone with humidistat. I think I know what the problem is. We left the measure. Yeah, we don't want this measure anymore. So this deletes the zone humidity control, which we don't want to do. So let's delete this and rerun it. Okay, this time it finished successfully. So let's take a look at the results. Air temperature, relative humidity. Here we go. Okay, so, wow. Our zone air temperature looks like it's being controlled pretty well here. Let's see. Drops down midday. Wonder why it does that. And then air zone relative humidity is it's actually being controlled pretty good here. So it's like in the 50s or so. Looks like it's set back in the evenings. It's in the 60s for the orange line, the relative humidity. And then during the operation periods during the day, when we're trying to control humidity lower down into 50, it's doing a pretty good job. So yeah, I think what's going on here is there's some bouncing around going on. I think so right here when it starts up, it's controlling to the cooling temperature, the cooling set point, which is 75, and it quickly drops the humidity down. But the baking operations start picking the humidity back up. And once it gets above our set point, a humidity controlled set point, right about here, that's when the unitary system kicks into dehumidification mode. And that tends to drop the space temperature down to 70, which is our reheat temperature. So 70 is our heating temperature, but it's also our reheat temperature for dehumidification. So so this period right here is when the unit's actually actively trying to dehumidify. So that's what's going on right there. Right. So let's close this and let's move on to the four-pipe system. So let me see. Let's open up our four-pipe system and let's see here. let's go to, yeah, right here. And what we're going to have to drag in our humidification and dehumidification schedules. We can get rid of this. So what we'll do is we'll add that previous model into here as a library file. And then we'll go to schedules and let's just drag in our schedule humidifying and schedule dehumidifying. Okay, so that brings in those schedules that we created previously that we can use for this project. Okay, so back to the HVAC tab. We're going to look at our four pipe system and discuss how to implement humidity control with this. Right, so the first step will be to take a look at the cooling coil. Yeah, so chilled water. Okay, so we'll go to the controller for the chilled water coil. And yeah, the only thing that we need to change on this is control variable. So right now it's just controlling to temperature. If we wanted to just do humidity control, so this chilled water coil would only handle dehumidification. We would just set to humidity ratio. However, what we want to do is do temperature and humidity ratio. So that's the first step. The next step is to add a setpoint manager to control the humidity. So for this, we're talking about dehumidification, and so we would do setpoint manager humidity-maximum. So we're trying to limit the humidity. So you drag this in, you have to put it right after your cooling coil. And we'll select this here. And then, so one thing that I'm just going to go off on a tangent here. We do have a humidification control, or a humidification schedule, a set point schedule on this. Like if we wanted to humidify the space when it's too dry. Now, obviously, we wouldn't do that probably in a bakery. Probably would never have that problem. But if you did, you would have to drag in a humidification source. So there's a couple of humidifiers. There's steam gas or steam electric. So if you wanted to do that, to add a humidifier to this, you would drag like an electric humidifier in here. And again, you would have to have a set point manager, but in that case, the set point manager would be a humidity minimum set point manager. And that comes right after your humidification equipment. So that's what that would be. But we're not doing that here. This is for a bakery. So let's go ahead and delete these here. So back to this, we have the humidity control. That takes care of the latent side of this coil, but this coil also needs a set point manager for controlling sensible, and that's just for heating and cooling the space. So we also need to have a set point manager, a single zone. Let's see, yeah, single zone reheat, single zone cooling. Let's just do that. So we'll drag this in here and drop it right on top of the same node. It comes right after the cooling coil. And then we can click this, and you'll see that we have two set point managers on that node now. We have a dehumidification controller, and then we also have a sensible cooling controller. And that should be all we have to do humidity control. And then, of course, this controller right here is our single zone reheat, and this will control the heating coil after the cooling coil. So it will provide heat to the space normally when the space requires heat, but then it will also actuate as reheat if this dehumidification process is in action in order to maintain the space set point. So let's go ahead and go to the thermal zones tab first. We don't want to forget to put in those humidifying and dehumidifying schedules. So let's put those in here. I want to go to my model and schedule humidifying, schedule dehumidifying, right? And then that should be it. We'll go ahead and run the simulation. Successful. We'll take a look at the results. All right. There it is. So, we have set back to space temperature set back to 80 at night. It looks like it is cooling to 75, basically all day long. And yeah, it is set back. The humidity is set back to 60 at night. Yeah, that's right. And it's keeping, yeah, it's doing a good job. It's keeping the humidity at 50 during the day. So you'll notice that there's no mode switching on this, and that's because we have two independent systems. We have a cooling coil system and a heating coil system. So it doesn't have to mode switch. Whereas if we're talking about a DX coil system, which operates as it has to satisfy two different needs, sensible and latent. Whereas this one, yeah, it looks like this one does a better job. And actually, I'm not entirely sure why that would be. We'd have to think about that. But at any rate, that's how you implement humidity controls in OpenStudio. Thank you. Please like and subscribe.